So we're going to look at solving quadratic equations again, but this time using your quadratic formula. And you learned this in the 10th grade, so again, it's still just a review for you. The only thing that's different is you're going to get imaginary answers now. And so we've already been dealing with imaginary numbers, so it shouldn't be anything terribly complicated. So basic, let me just remind you that this is a quadratic equation because it has a quadratic term. For my highest power, it's got a 2. It's followed by the linear term and the constant, and it's all on one side equal to 0. This is what I'm going to be talking about every time that I say that it is in standard form. Standard form means that it's quadratic, linear, constant, all on one side equal to 0. If anything's missing, that's fine, but you're still going to put it in order according to what you have. You know your quadratic formula, it's x, or whatever your variable is in your problem, is equal to the opposite of b. So you always change the sign on b, plus or minus. In the radical, you're going to do b squared minus 4ac, and all of that is going to be divided by 2a. And the thing I want to focus on that'll help us with this, with the imaginary stuff, is this thing called a discriminant. And I don't know if you've been taught the discriminant or not. Different teachers teach it different ways. I'm going to show you the discriminant. Your discriminant, if you'll notice, is the b squared minus 4ac. It's the thing that is inside the radical. And so if you go ahead and identify what that discriminant is, if it's a positive number or a negative number, then that helps you out with knowing how many roots you're going to have and what kind they are. You can have real answers, you can have imaginary answers, you can have one answer, or you can have two. So, here's what it looks like. If your discriminant is bigger than 0, for instance, let's say the square root of 4. If you take the square root of 4, you get plus or minus 2, which means you have a positive 2 or a negative 2. Those are my two real roots because I took the square root of a positive number. If your discriminant is 0, you're only going to have one real root because remember, this is the square root part. And so if I take the square root of 0, I get 0, which means if I were to put in the square root of 0 right here and the 0, then really all I'm going to get for my answer is the opposite of b over 2a. That's the only answer I'm going to get. That means the vertex for that quadratic equation is sitting on the x-axis. Alright, the last one, your last possible option is that d, your discriminant is less than 0. It's negative. Like the square root of negative 9 is going to give me plus or minus 3i. So that gives me a positive 3i or a negative 3i for my solutions. Those are my two imaginary roots. That means that this graph of this quadratic equation, whatever it happens to be, will never cross the x-axis. This one crosses it in two places. I'll show you real quick what that looks like. If I had this one, it would look like this. Two real roots. If I only have one real root, it's going to look like this. Mind you, it could open up or down. It can cross anywhere or it can touch anywhere. Or if I have two imaginary, it would be the one that's either above the x-axis and it goes up, or it's below the x-axis and it goes down. That's what your solutions are going to look like. And we're going to get into graphing later on, so just maybe tuck that away for later. So let's start with just basic, finding the discriminant. Yes, I'm talking kind of fast because you know I'm watching the clock and I'm making sure I get all of this in 15 minutes. So stop me, back me up, rewind me, listen again, whatever you need to do to comprehend what I'm telling you. This is easy stuff. First of all, make sure that it's in standard form. It is. Identify your A, your B, and your C. It's got to be the quadratic, the linear, and the constant. And then just find your discriminant. Your discriminant is b squared, and you need to put that in parentheses and square it, minus 4 times A times C. So the reason I stress the parentheses is if you want to use your calculator for this, you can. I'm going to do negative 10, and make sure that's a negative and not a subtraction. Negative 10 squared minus 4 times negative 7 times negative 8. I got a negative 124. That means I'm going to be taking the square root of a negative 124. That means that I'm going to have two imaginary roots. That means there's going to be an I in my answer. So I know ahead of time to look for that imaginary part of my answer. On the next one, not in standard form, use your inverse operations and bring everything to one side. Find your discriminant. Sorry, I almost said the wrong thing. Is b squared minus 4 times a times c. So I'm going to get b squared, we'll type it in for you, minus 4, times a times c. And I get 1. That's a positive number, obviously. If I take the square root of 1, I'm going to get 1. So that means I've got a real number answer. I'm going to have 2 real roots. Okay? Look at number 3. Not in standard form. Use your inverse operations and bring everything over to one side. So I have negative 11k squared minus 4k minus 1 equals 0. There's my A, my B, and my C. Plug it into your discriminant. Your discriminant is b squared minus 4 times A times C. Plug it into your calculator, just like that. B squared minus 4 times A times C gives me negative 28. So my discriminant is negative 28. That means I would be taking the square root of a negative number. That means I'm going to have 2 imaginary roots. That means I need to make sure there's an I in my answer. Okay? Number 4, not in standard form. Get it that way, so I'm going to subtract 8 from both sides, and I get negative 5x squared minus 6x minus 9 equals 0. There's A, there's B, there's C. Find your discriminant. B squared minus 4AC. And so I've got B squared minus 4AC gives me a negative 144. Taking the square root of a negative number, 2 imaginary roots. That means there better be some I's in my answer. So now let's put that quadratic formula to work, and hopefully I can do this quick enough to get through. Find that discriminant first, because I'm going to show you why I think it's easier. Just me. Your discriminant is b squared minus 4ac. Plug that in your calculator, and you know ahead of time now, because there's my a, there's my b, there's my c. So you'll know ahead of time what you're taking the square root of. So I've got negative 10 squared minus 4 times 7 times 5, and it gives me a negative 40. So in my quadratic formula, which is right here, guys, just flip back over and look at that. It's on the other side of it's on the left-hand side of your paper. So my variable in this one is a, is equal to the opposite of this, so 10 plus or minus the square root of my discriminant, which we just said was negative 40, over 2 times a. So I can't plug this in my calculator with that negative, but I can do this. Hit that fraction button, type this in exactly like it is, with the exception of putting the negative under the radical. I already know that 40 is not a perfect square, so I can do this on my calculator. So 10 plus the square root of 40, not negative 40, over 2 times 7, and I get this. So this calculator flips around and puts the real number last. I want you to flip it around and put it first. So it's going to be 5 plus or minus I times the square root of 10 over 7. And the I is there because I took the square root of negative 40, and it's got to come out to the front of the radical. Okay? Looking at number 2. It's not in standard form, so I'm going to move this over, and I get 5v squared minus 12v minus 65 equals 0. There's my A, my B, my C. I'm going to find my discriminant. Is b squared minus 4ac. So I've got negative 12 squared minus 4 times 5 times negative 65. Ugh, it's a big number, 1,444, but it's positive. I'm going to check real fast with that big of a number and see if the calculator will simplify it. Oh, beautiful. That was a perfect square. So here's what I got. I've got my variable is v is equal to the opposite of b, so that's going to be a positive 12, plus or minus the square root of 1444 over 2 times a, which is 5. So if you already know this is the square root of 30, that this is 38, if you do this fraction, type it in, 12 plus the square root of 1444 over 2 times 5 is 10. It gave me 5. That only takes care of one of my answers. I've got to go back and do the same thing, but change that to subtraction. So I'm going to do it the lazy way. You can retype it if you want to, but I just need to go and change that to 12 minus, and that gives me negative 13/5. Those are my two answers. I'm already at 11:22. I got to move fast. Put it in standard form. Just bringing everything to one side, using my inverse operations. There's my A, there's my B, there's my C. My discriminant is B squared minus 4AC. I'm pulling a football trick and I'm calling for timeout so I can save the clock, okay? So I just typed it in my calculator, I pressed enter, and I got 616. That gives me a positive number. I just typed that in. And so my discriminant is 616. That means I'm going to find the square root, I'm going to find that k is equal to the opposite of b plus or minus the square root of 616 over 2 times a. So I'm going to real quick take the square root of 616. It gives me that, so I know that I'm good. Sometimes it'll give you a decimal, and that's why I'm checking ahead of time. So I'm going to plug it in and get my answer. Again, I'm cheating just a little bit by using the pause button so I can get more out of my time here. I'm just playing the clock. So here's what I have. Make sure the real part comes first, the whole number comes first, plus or minus. As long as there's a radical still in your answer, you don't have to go back and do it twice. If the radical drops out, you have to re-enter this with the minus in the middle. So there's 1 plus I, not an I, because that was a positive number. 1 plus or minus the square root of 154 over 9. And the calculator has simplified it for me. Those are my two real roots. Looking at number 4, I've got less than 2 minutes. Get everything on one side using your inverse operations. There's my A, there's my B, there's my C. I'm going to find my discriminant real quick. So my discriminant is a negative 119. Please pause and do what you need to do to just check me, but I've got negative 119. That means when I find X, it is the opposite of B, plus or minus the square root of negative 119 over 2 times A. I'm going to plug that in my calculator without the negative. Alright, so I plugged this, that just blanks it completely out. I plugged this into my calculator without the negative under the radical, and I got this. It didn't change. So X is equal to 5 plus or minus, you got to put the I because that's negative, I times the square root of 119 over 24. Those are my two answers. It's 5 plus I squared, it's 119 over 24, and I minus. Pause the video, do the next 3 on your own, and come back and check your answers and check your work. I will show my work. Alright, I've got 45 seconds to explain anything, but I've shown you my work. It was in standard form. My discriminant was negative 31. Plugged it in without the negative in the calculator, and this is what I got. Wasn't in standard form, so I subtracted the 12 from both sides, and that's where the negative 9 came from. My discriminant's a positive 144. That's a perfect square. So the square root dropped out this time, and that means I had to put it in twice. I had to do negative 6 plus the square root of 144 over 6, negative 6 minus the square root of 144 over 6. Last one, I got 10 seconds, not in standard form, so I added 8a to both sides. My discriminant was negative 332. Plug it in without the negative, and there's my answer.